Okay, so hi everyone and welcome to this next senseFly Academy session about flight planning for inspection. My name is Andrea, I'm from senseFly, and today I have with me Ben, our application engineer for albris. Ben, I pass to you.
So first of all, I would like to thank you all again for joining us today for this webinar. And I really hope you will find it really useful for the job you have to do with the albris. So let me show you the plan for today's webinar. So first, we're gonna talk a lot about preparing a mission. It's a really important step. It's really the key step for having a successful mission. So we're gonna talk about planning the flight path around structure and also estimate time needed to perform an inspection. Next step, it's gonna be flying the mission. We're gonna talk about flying your albris close to structure. We're gonna talk about ensuring picture quality to have the best result as possible. And then also talk about the communication link. And for finishing, I'm going to give you some tips about how to process the best your close inspection dataset. Okay, here we go. First slide. That takes some time to come. I don't know why. Prepare. Okay. No, too bad. Okay. So first, when you are preparing your mission, the first thing you need to do is to gather information about the structure and its environment that you're going to inspect. So you need to require from your customer, you need to require drawings all the picture that he has about his structure. The best things to do is to visit the site. Now we have a very nice tool online with Google Street View that can bring you everywhere. So it's good to be aware that everything that is around the structure, but for a big inspection, I would still require you to go and sit by yourself. When you're there, you can spot the different access to the structure. It's really important because it's from there that you will be able to fly, okay? So spot any area where you can do your takeoff and landing, and also spot all the obstacles that are too close to the structure. For example, a tree that is too close to a wall that will block you the access to the structure, or you need to be to tell the client that there's no way you can inspect behind a tree, for example, and this kind of obstacle need to be foreseen before flying. And another thing really important, you can look for reference on the structure that can be used for flight line. For example, especially on a concrete structure, usually the formwork leaves some marks on the structure that have a regular spacing. Well, those can be great to give you a good guidance when you will fly your drone. Okay, now you've seen your structure, you know what you are going to inspect. Now you need to define the distance to the subject. So for this, there are some questions you need to ask yourself. First, the client might require a resolution. So if you require a resolution, then it's you don't have to ask the question too long. If you require 0.7 millimeter per pixel, but you know you're going to have to fly at 4 meter. But if you have the freedom to choose what distance, then you need to talk with the client what kind of details, what resolution do they want to have on its inspection. And also different structure will require different resolution. For example, a stone structure doesn't need to have a a high resolution because usually the defects are big and the stone is rough. But on concrete, if you need to spot fine cracks, then you will need to fly closer. So this is really the most important factor to decide, because the closer you fly, as you can see on this table, the smaller is the footprint. And of course, the smaller the footprint, the more picture you will have to take to cover the whole structure. And while flying at 2 meters or flying at 4 meters, you can see that there's a huge difference on the area cover per images. So there's a factor that is greater than 2 if you double the distance. So it's really the parameter you need to pay attention the most. Once you figure out the distance you're going to fly your structure, then you can start taking attention to the overlap you're going to use. So for that, there's a table here. It's also available on the knowledge base article. There will be a list of all the knowledge base articles related to inspection at the end of this webinar. So once you know your distance, you need to choose the speed of the drone with it's basically the cruise control speed that you're going to apply to the drone to have a semi-automatic and a good overlap. So here, for example, you see if you fly at a distance of 2 meters, well, basically you cannot go much faster than 0.1 meter per second. Otherwise, you don't have a good overlap, and the reconstruction will be extremely difficult, if not impossible. But if you fly, for example, at 4 meter distance, then you can go up to 0.2 meter per second, so you will already go twice as fast and cover greater surfaces per flight. So you can see there's 2 tables, because you're going to either fly up and down with the drone or left or right. And since the pictures are rectangle, there's 2 tables to have those 2 different kind of configuration. Okay, so now you have your distance and you know what speed you're going to do. Now you really need to think about your flight plan. Okay, so in one direction your overlap is secure with the distance lock and the cruise control, but now you have the lateral overlap that is more manual, that is more flexible. So this is here in this section, for example, that you can use the marks that you saw on the structure. For example, if you saw that there's a vertical form work line every 2 meters, but you can use this line to create your flight plan. If not, well, you can choose the distance yourself. So you need to calculate what lateral overlap you want to put. So I would require to have 66% at least to have an easy reconstruction afterwards. Okay, so in this example I took 3 meters, so you can put a mark every 3 meters at the bottom or the top of your structure and fly along those vertical lines to ensure your lateral overlap. So here I put you 2 examples. So there's one with a minimum overlap. Okay, there's about 30%, and the one on the right, you can see that the lateral overlap is much greater. Okay, but the longitudinal overlap is lower. So it depends the type of structure you have in front of you. If it's very high and narrow, well, you can have the drone that go faster, but put more lateral overlap. If it's very wide and not so high, then you can put higher vertical overlap and less longitudinal overlap. Here it's up to you to see what's the best depending on the structure. So here another example of how to plan an inspection. This is the example of the dam that we inspected last year. So from the operator of the dam, I was able to get a drawing of the structure. Okay. So then it was pretty easy for me to figure out how many flights I'm going to have to do. So I simply drew the vertical flight line I was going to fly. Okay, so I just drew it in AutoCAD. I adjusted the flight line with the bottom of the dam. Then I exported those lines to an Excel table, but you can already also do those calculations in AutoCAD. Then I simply calculated the total length of all those lines. So it gives me in the end the total number of pictures I'm going to have to take. So you can see here it was about 7,000 images. Since I know the speed of the drone with the overlap I calculated earlier, I already know how long the drone is going to have to fly. And by dividing this total flight time by, for example, 15 minutes per flight, I know how many flights it's going to take for me to inspect this dam. So you can see it's really a good way to estimate. For example, here on this project we estimated 48 flights, and in the end we inspected the whole structure in 50 flights. So it shows really close to the reality. Now let's talk more about additional flight line. So depending on the structure, I just talk about vertical wall, so it's the easiest flight path you can have. But some structure require additional flight line. For example, on a bridge, you need to add a flight line around the edge. This is really important if you, when you process your data set in Pix4D or other software, if you want all the surfaces of your bridge to be connected all together, well, you need to have pictures where both those surfaces are visible. Otherwise, Pix4D will not be able to connect two corners. For the human, it's pretty easy, but for the software, if it doesn't have a key point you can match on both surfaces from similar images, well, then it will not be able to know that those two walls are next to each other. So that's why on the angle you need to have images with a 45 angle of view to connect those two surfaces. So you can see I put it here, two colors of arrows. The red arrows are the one where you can use the distance lock because it works vertically and horizontally. And when you are going to do the connection additional flight line on the edges, you will not be able to use the distance lock. Okay, so you can see here the example on a bridge, and it's also true if you are at the corner of a building, well, you need to add at least two flight lines to connect if you want those surfaces to be connected. If you are not interested in building a 3D model of the whole surface is connected together, then you don't need to do those additional flight lines. Okay? Now that we are ready for the mission, we know where we're going to fly, well, we get on site and we get ready to fly close to the structure. So first advice, always fly in no GNSS mode close to a structure, especially under a bridge or close or under a structure. Okay, this is really important to have the best behavior as possible with your drone. You don't want, for example, unwanted return to home when you are under a bridge, or even close to a structure in a city. You don't want the drone to navigate where the GPS signal is potentially disturbed by surrounding structure. Other advice, set all your auto trigger setting and speed control before takeoff. It would be easier rather than doing it during the flight. Okay, so set up your auto trigger and cruise control speed. You take off, you put your drone in place, then you just need to start the auto trigger and you can save some flight time. When you fly close to the structure, when possible, I will also advise to stay in direct line of sight, just to always be have the possibility to take direct control of the drone. When you have to fly with the screen, or sometimes it's better, always keep also an eye on the drone and be aware of potential obstacle around the drone. If you don't look at the drone for 10-30 seconds, you have the cruise control on, and you can get close to a pier on the side, or if you fly up, you can get close to the deck. While you need to keep in mind that the drone is moving and there are some potential obstacles around the drone. Also use the distance lock or the bottom ultrasound when you are in range of the sensor, because it will improve the stability. Because you need to have a US sensor activated to do the optical flow. So the optical flow will bring more stability to the drone. So I would advise you to either use distance lock or have the bottom ultrasound activated to have the drone more stable. Last advice, but not the least, always be ready to trigger the anti-drift off. It's especially when you see that the drone starts to drift too much. Okay, this is for now the only procedure then that will give you a direct input on the drone. So this is here for some reason, of course. When you are close to structure, the drone will still use the GPS to help the stabilization, because it's always better to have GPS close to the structure rather than nothing at all. But it can happen, especially close to structure with metal, or where the GPS is really disturbed. You can have some effect on the stability of the drone. Also, when you are in condition where you don't have GPS, where the optic flow is not able to work, you can also be in a windy condition. Well, the autopilot of the drone only have its IMU and gyroscope to ensure the stabilization and the speed control, and sometimes it's not enough to maintain a good anti-drift, and it's sometimes better to have a direct control on the drone than stay with the anti-drift on. Next question, it's about now the picture quality. So first advice, when you are in dark condition, it's better to activate the flashlight, sorry. So some additional advice: if you want the flashlight to work, you need to have the ultrasound activated on your head, because we need to know how much power to put in a flash. For example, if you are at 1 meter, the level of power required is not the same than at 5 meters. So we need to know that distance to put the right amount of power in a flashlight. That's why you need to have the ultrasound activated. Also, if you are in really dark condition, or if you are 5 meters away from the structure, so you need the maximum power on your flashlight, then it will need some time to recharge, and this have, of course, an effect on your overlap and your speed. If the flashlight need 10 seconds to recharge, then it's 10 seconds where you can't take good images. Another point, to ensure the good picture quality, you might need to lock the exposure setting, especially when you have potential sky or a lot of light in the background. So here for you I put two examples. So on the left you have actually a bad example when the exposure was not locked. So, and well, I came to fly at the edge of the bridge, and a lot of light came through the space between the deck, and of course the exposure well, adjust the exposure setting according to the light, and of course in those conditions you can't see the deck anymore. But with the exposure locked on the right, you can see that although a lot of light is coming from the sky, of course this part of these images is overexposed, but we don't really care, because what we want to see, what we want to have, it's the good exposure setting on the concrete and not in the sky. So this exposure lock will make sure you always have the best exposure setting, even close to the edge of a structure. Some more advice when you are doing a big mission and you acquire a lot of images. It's very useful if you use another laptop and 2 SD cards. So the idea is to, after performing your first flight, you take the SD card out of the drone and you start the FDM procedure with another laptop, because it takes some time to import the images and also to convert them into a JPEG for processing. In the meantime, with the other SD card and the other computer, well, you can keep flying, so you don't waste time at the end of the day having to convert 2,000 images, which can take a lot of time. The other advantage of doing that is, as you acquire the images, you can also check the image quality. It would be bad to take all your picture, come back home and just check for quality when you're back, and then there's nothing else you can do about it. So if you check the quality on site, you can always redo a flight. If, for example, you notice that the camera was dirty, or the autofocus was bad, or the exposure was too dark. Another thing to pay attention is the yaw of the drone, to make sure that you ensure a proper overlap. So when you calculated your overlap earlier, you consider that the drone was perpendicular to the structure you inspected. So when you fly, you need to make sure you are as the best as you can in that condition. And this figure here shows you that if you already have a 5 degrees deviation, well, you already lose 40 centimeter on one side of the image, and if you go at 10 degrees, you lose well 75 centimeter of overlap. If you let that, if you don't correct it, you might end up with a gap between your flight line. So always make sure that you keep your drone perpendicular to the surface you are inspecting. Then the further away you fly from a structure, the bigger will be the importance of keeping the drone perpendicular. Now we are going to talk to you about ensuring link quality, and for this I'm going to let Luis to talk to you about this.
You need to check before flying or while flying, you need to check the environment. Okay, sometimes you will be flying in a city, sometimes you will be flying away. So if you are flying inside a city, on the city center, you need to check that the other communication devices you may have during the flight. So you will have other networks, other Wi-Fi's that may interfere with your communication system. For that, you have a good, I will put you in the chat right now, the web, okay? It's a knowledge-based article we have to help you improving your communication, okay? So on that article, you can see that we suggest to use a little software you can use using the Wi-Fi card from your laptop to check for the different networks you may have in your area. Okay, there are other versions that are available for the cell phones, for Android, for Apple devices that makes the same thing. Okay, so the idea is to check which frequencies are used and to use always a different one. It's not a good idea to share some kind of frequency, some kind of channel between several devices. Okay. After you, of course, you need to check some other things. You need always to be in direct line of sight with your drone. Okay. It's not a good idea to try to fly behind a building, for example, behind on the other side of the structure, because if you don't have a direct line of sight with your drone, you may have some kind of communication problems. Sometimes it may work, but we don't recommend you to do it because the communication system we use it needs a direct line of sight. Okay. After, something really important is to correctly place the antennas. Okay, so right now you can see me, guys. Something really important is how we put the antennas. Okay, so many people think that we need to point with the antenna to our drone like this. So on this direction you will be flying there, and we put the antenna pointing there. It's not a good idea, because that kind of antennas are omnidirectional antennas, and they have some dead zone on the line. Okay, so this is the axis of the antenna. So we have a dead zone on this direction. Okay, so we need always to put the antenna perpendicular to the drone. Okay, always put your antennas like this. Never put both like this in the same direction, so both perpendicular and in slightly different angles one from the other. Okay, so like this we will be able to cover more trajectories for the communication system. Okay, after if you have maybe you will have sometimes problems with this kind of antennas. Okay, you are trying to fly really away, near to 1.5 kilometers or even more. Okay, on that kind of cases, I recommend you to use our new communication antenna. Okay, that is something like this. Okay, is a directional antenna of both 2.4 and 5 gigahertz, same thing as the antennas from the modem. And it's really easy to use, and it's really easy to retrofit. We can say retrofit your modem to use it. Okay. The only thing you need is to unscrew both antennas from your modem. Okay. Here you have support for the modem. You can clip the modem on the base of the antenna, and after you can screw both pigtails to the connectors. You don't need to use some kind of X key driver to put these nuts on. Okay, with your hand you can tie it like this, and right now your system is ready to be used. Okay, you can use this screw to put a tripod. Okay, we really recommend to use a tripod when using the communication link, and we recommend, and as you will see right now in the presentation, we recommend always to avoid putting your modem over your car's roof, over a metallic structure, away from metallic structures, away. Okay. So first, the most important thing, maybe, or the most important option is a tripod. If you don't have a tripod, well, another kind of something like a cardboard box, but never over the roof of your car. Okay, and it's really important also to use always our provided USB cables. We are sending so many data from the drone to the computer, and we need high-speed cables. Okay, our provided cables are really certified by us, are really tested, and if you use some other USB cables from another devices, something like the white cable that comes with the Canon camera, that is really thinner than the one we provide with the albris, you may have problems. I'm not telling that you for sure will have problems, but you may have problems with the quality of the data sent. Okay, and I recommend you to check the article on the knowledge base that explains you how to use the little software to check the Wi-Fi networks, how to put your antennas, how to use one directional antennas, omnidirectional antennas, and all stuff. Okay.
Okay. Well, thank you, Luis, for your advice. Now we keep carry on with our presentation, and now we're gonna I'm gonna give you some advice for the processing of your dataset with Pixel. So here, really, of course, critical phases of the work is to do the. So you can save a lot of processing time, avoid the calibration mistake, and reduce the size of the output by choosing optimized processing option. Okay, so this is something I've been working on for a lot of time with all the data set that I did with my albris here on different kind of structure. Then by comparing different processing options, I came with Pix4D on the best processing option you can choose for close inspection. So first, for the initial step, I will recommend you to change some settings. Okay. So first, on the general setting, you can use the image of half the scale. The albris images have a 38 megapixel resolution. to realize the initial step, you can easily use just half the size of the image and the result will not be affected by doing so. The only good, the good point you will get from that is to reduce dramatically the processing time. Same goes with the calibration setting. By default, if you let Pix4D do, it will calculate almost 100,000 key points per images. First, it takes a lot of time to calculate all those key points, and then it takes even more time trying to match them all together. So you can reduce those number of key points. You can go down to 9,000, up to 15,000. It will actually bring a better result than putting too many key points, especially on homogeneous surfaces like concrete. What can happen is that well, the computer do some mismatch because it all looks similar. Concrete is rather homogeneous, and by reducing the scale and the number of key points, well, you improve your chance to have only good calibration images. Okay. Another point to think about is the geotag that you acquire close to a structure. They can sometimes be really inaccurate, especially if you have a GPS disturbance. Okay, so you can understand why it's not that easy to stabilize a drone close to such surfaces. Okay, so what you can do to avoid having different blocks created in Pix4D is to lower the geolocalization accuracy that is recorded in the images. So by default it stays on custom, but you can go and press standard if you are doing a facade, and if those geotags are really off, or if you flew the bottom of a valley with almost no GPS, then you can put this setting on low, because you have all chance that anyway this accuracy on those geotags are really bad. Second step for the densification. Well, again the albris camera is a 38 megapixel, so you get a lot of details. And if you use the default setting, well, Pix4D will create you a very nice point cloud, but really, really dense, like having a point every 3 millimeters on your structure. It's nice, but it's not really useful. You will have two issues from that. First, the densification will take forever. So you will lose time in the process of producing the output for the customer, and also, well, the size of the point cloud will make it really hard to handle, to export to other software, and in the end you don't need to have a point every 3 millimeters. So you can really easily reduce the point cloud density here. You can put the image scale on a quarter and the point density on low. It will bring you a point density that is still more than enough, and you will make the densification step much faster. Instead of processing for days, you can do it in one night. There's also one setting that is interesting in this step. It's the number of matches that you can play it with that figures depending on your data set. So if you did a project and you are sure you have sufficient overlap and you are doing around a 3D object, for example, you can set the limit on 4. or even 5, and this will limit the noise around the edges of your structure. You might have noticed sometimes you have some point of sky or noise of trees in the background that come close to the structure. Well, if you increase the minimum number of matches, you will reduce all this noise around the edges on your dataset. On the contrary, if you have a minimum overlap and, for example, especially for big structure, for example, a dam or a big wall, you might have set up a minimum overlap configuration, and sometimes the wind pushed the drone, or you didn't keep the drone correctly on tracks, and you might have some area where you don't have 3 images covering an area. Okay, so if you want to limit holes in your data set, well, you can here put the minimum matches on 2. Of course, you will lose a bit of geometrical accuracy on your model, but if you are interested in producing orthophoto for defect reporting, you don't really need to have this accuracy anyway. Okay? So to help you setting all those setup, I created a template that is available on my senseFly, on the knowledge base. So you can later just click on this link, download the template, and use it for your own processing at home. Some more advices for big projects. So with the albris and big structure you can inspect, you quickly acquire a lot of images. So depending on the capacity of your computer, it can be faster and better to divide the project in different blocks that you process separately, and then you can merge all together, or just produce output from different sub-projects. If the project lasts for a few days, I will suggest you to process every night what you acquire during the day. You just need to do the first step, okay? So you will see if the project works, if your overlap was enough or not, and if you didn't miss some area, if you don't have some holes in your project, so you can already check every day the processing. After that, when all the sub-projects are ready, so you've done the first step, you can merge them all together. Then you need to re-optimize and carry on with the workflows of densification and creation of your autoplane. So with all this good advice, well, I hope that you will be able to make some great data set. So here I just show you some project that we have been doing on our side. So the dam and a nice ceiling structure in front, but also you can see on the right a section of a bridge. That's a 3D model, and well, it's just to show you that the albris has some good capacity, good possibilities to get close to structure. It really makes the flight easier, and you can ensure a good picture quality, and you can also create some very nice data set out of that. So here is all the list of my senseFly and knowledge base article, and you can have a look. So every point that we talk about today, all the tables, all the advice are available on different articles. So here's the list. So you can ingest what we all say to you and go back later on those articles to really make sure you understood, and it will hopefully make your next job a bit easier.
Okay, thank you, Ben, for this presentation, and also thank you to Luis. Thank you for joining today.